Hey guys, welcome back. In this video we'll be talking about increasing and decreasing functions. The whole goal of this video is to talk about when a function increases and when it decreases, and also what it means for a function to increase and decrease. Where this is a calculus concept that requires the first derivative test, and we'll eventually get there to calculate it, but I can show it graphically. So let's just hop right into it. Okay, so first let's determine some terminology. Alright, so we say a function is increasing when the slopes of the tangent line are positive. Alright, that's in a calculus perspective. Now, if we can use the difference quotients, which is the average rate of change. The average rate of change, and if that is positive as well, the function's increasing. Also, so we say a function is decreasing if the slope of the tangent lines oops, you guys can't see that. Lines are decreasing. And same thing for increasing. The difference quotient is negative. Okay, difference quotient is negative. Okay, so also we could say a function's increasing is if its rate of change, if the rate of change is positive. And we can say the rate of change, and it's decreasing if the rate of change is negative. Okay, so now with that, we can say functions are constants. So when are functions constant? So what a constant function means is it's not increasing or decreasing. Sorry guys, let me get that center back. It's not increasing or decreasing, and also it's there's no rate of change. So the instantaneous rate of change, the slope of the tangent lines are positive for increasing. Or the instantaneous rate of change, or the average rate of change, the difference quotients of the function are positive as well. And which we can say the rate of change, both rate of change are positive, and we can say that's another form. A decreasing function means the slopes of the tangent lines instantaneously. If we're trying to find when it's at a certain instance, when functions increase and decreasing with intervals in an instance, we can slopes the tangent lines, and we can say if they're negative, they're decreasing. If the difference quotient is negative for the average rate of change, it's negative, and it's negative, it's decreasing. Or if it has a negative rate of change, so a positive rate of change, think of it as a positive sloping line going through the origin. If you guys remember this in the graph, oops, let me just sorry about that, guys. Let me draw a straight line going through the origin at a 45-degree angle. All right. So if we get something like that, we could associate this with a positive rate of change. Okay, rise over run, and the rise is positive, the run is positive. We don't go down, so it's positive. It's a positive rate of change. Whereas the decreasing, if you guys remember what a decreasing looks like, it's a negative sloping line going through the origin. Okay. So rise over run. All right. So we go down and over rise over run, and it's negative. So this is a negative rate of change. Okay, so constant means so if there's no rate of change, it means the rate of change is the exact same. So slope of tangent line is 0, or the difference quotient is 0. Okay. Now, Sorry about that, guys. I'm gonna zoom in for a second. So let's take it to an example submitted by a viewer. All right, and we have four line segments. All right, this is a piecewise function. I intentionally just left it out, and we call this function f. All right, and pretty much, if we have if we have four different line segments, A, B, C, and D, we're asked to find when are they increasing and decreasing, or if they're constant. Okay, so starting with segment A. All right, if we trace it through, all right, is there any rise over run? Well, there isn't. All right, there's no rise, but it runs. It just stays running the whole time. It stays constant. So there's no rate of change. So this means this is constant. The slope is 0. So that means line segment A is constant. All right. So line segment B. All right, line segment B. So pretty much, sorry about that, guys. Line segment B. So what we're going to say is, okay, same approach. Is the line segment right? Is the slope positive or negative? All right, if it rises over run, so the rise over run is positive. So the slope is positive. Sorry, I'm bad at drawing at an angle. This is a positive slope. As you guys can see, we go up and we go over, and it's positive. So this is a increasing slope means increase of function. Okay, point C. So same approach. All right, we rise over run. Well, it's falling. The function's falling. Tracing it down, you can see it's falling, and we go to the left, and it's going down. The line's sloping down. All right, this line segment is a negative slope. Which means this is a decreasing. All right, and line segment D, or last but not least, it's sloping upwards, so it's rise over run. So it's increase. So the y values are increasing, the x values are increasing, meaning the slope is positive. Positive slope, meaning that it's increasing. All right. So just to recap, sorry for the shakiness, guys. I still haven't got a camera stand quite yet. But so going back to this, a function is increasing if the rate of change is positive, or meaning that if the slopes are positive, the slope at any instance is positive. All right, a function is decreasing if the slope if any slope of a function at any point is negative. That means it's starting to decrease. And a constant function means it's neither increasing or decreasing, meaning the slope is 0. It's not rising or running. The average and instantaneous rate of change is 0. With that being said, guys, we'll talk to you guys later, and see you then.